Morning, ladies and germs. Let's see. I got some. I was cleaning up today. I know it doesn't look like it, but I got a letter here from Buzz from August of 2017. This is now January of the next year, and I got something from Lil Doggy as well. I can't even read it. It's been so long. Papa Texas's letter opener here. I figured we'd give it a shot and see what's going on, and at the meantime give you guys a channel update, see what I'm doing, what I'm working on. And let's see, yeah, Buzz gave me a couple stickers here. Nice. There's a nice note on there. He's been enjoying the videos. Let's see, if your videos are an indication as to what's going on inside your head. Yeah. Yeah, the whole lot. That's funny. Yeah, thanks, Buzz. I appreciate it. That's great. That's great. And I'll find a nice spot for him. All right. I'm sorry, guys, so late, man. It's nothing personal, really. Let's see. Yeah, he puts out some decent stuff too. He's got a lot of ham radio stuff going on. Likes to play with that, and this is duct taped up. I need something to cut this with. Let's see here. What do we do? There's nothing in it. Lil Doggy, you are something else, buddy. It's all right. There's nothing in it. But he does have a very, one of those very nice things to say on the back. I like his channel for that. It's always got some positive reinforcement stuff going on in the back. It says, worrisome thoughts are notoriously inaccurate. Don't believe them all. There it is. Well, thanks a lot, guys. I really appreciate it. I'm going to try to stay on the ball this year. Last year was a nightmare. Anyway, some of the things I'm working on. Let me turn the camera around here real quick. There we are. Let's see. Here's a schematic for an induction probe. And let's see. Mosslack, Doug's electronics workbench. He was talking about. He was working on one of those Heathkit signal tracer. This is basically a signal tracer. I did this about, I don't know, 2000 I don't know, 4 years ago, four or 5 years ago, and I put it in this enclosure here. As you can see, it's been around, but it's got one button, and it goes to this probe where I can hook it up to a let's see, I got an RJ11 and an RJ45 jack, and I got some clips on there, and you just get close to the wire. Let me show you. You just get close to the wire, and you can detect the wire. So that's really nice if you're working on like telephone lines or network cables, and they're all in this big wire closet, and you need to detect where they are. So yeah, this thing saves me a lot of time. Buying one, they cost about 50 bucks each. 50 bucks for that, and they usually charge 50 for that as well. It's about $3 worth of parts. The enclosure, I think, is worth more than anything. But it typically uses just a 386 audio op amp, classic chip. Small MOSFET. That would be the induction probe there. I'm not sure if we're getting good picture here, no? And yeah, there we go. So yeah, it uses a 386 audio amp, classic chip. It's tiny MOSFET. Here's your inductor probe, and I have a 10 microfarad capacitor going through that, Doug. I think at one time I had a 100 nanofarad cap going through there, but I found that in this particular application, this one, the 10 microfarad actually worked better. It filtered out a lot more stuff. It wasn't so. It's a lot more discriminating now. So it stopped a lot of false signals, stuff like that, or just simple radio from coming into the and through this. Like if I take this and put it up to my cast iron radiator, I can get a radio station come out of there. So yeah, these things, you want them sensitive, but you don't want them too sensitive. You want them to be focused to what you want it to detect, right? And it uses a 9-volt battery and a simple 8-ohm speaker. And I drilled all the holes for this using my my drill press, and I countersunk the holes. And I have another one of these enclosures, and this plastic thing came from a Wii mic, one of those Nintendo Wii things, and it certainly takes a beating. But yeah, that thing's been in my tool bag for years, man, and I love that damn thing. Let's see, what else am I working on? Yeah, I'd like to get you the plans for these. If anybody wants them, I'll make a video on that particular thing alone, and we'll go over the whole process of what's going on, the design of the circuit board, the type of enclosure it is, complete bill of materials, and you can go and make one yourself if you wanted to. And of course, I'll have the schematic and an enclosure built specifically for basically a complete copy of this. So we'll just do a replica of that. Let's see, next. This is a digital soldering iron controller. This runs off of a PIC, the 18F, the 18 series. And let's see. Yeah, it's a nice little project. I didn't write the software for it. The hardware, it's been geared for what the parts that I had available. So let's see, and it's a 2-page board, and I have another board here. And let's see what happened to it. It worked for about 3 or 4 years, and then just I don't know what happened. The damn thing just started messing up. I think it was the board. It's corrosion on the board and just time. And other than that, the thing works fine. I have it right here. Hold on a sec. Doesn't look pretty. There it is there. Alright. And yeah, I got it apart. So I'm just redoing the board because this was the prototype board for it. And as you can see, I had to do a lot of rip-ups. You know, rip the parts up, put them back on. A lot of testing. And yeah, so I'm just going to respin the board because this thing's the board is too thin. And I think that's what happened to it. I think it's just too much thermal cycling, stuff like that. And I think because of the thickness of the board, I think maybe pushing down on it too hard when I was doing a calibration one day, and I think it just shit the bed. So yeah, I mean, it does fire up, but it doesn't act right. Anyway, so I'm gonna respin the board, and that will have a complete bill of materials as well. And you can see I made the front panel out of a circuit board. And yeah. This runs off of both AC and DC, so you can run this off of a car or a vehicle battery, 18.3 volts. You can do that, which is really nice if you needed a soldering iron in an emergency. And you can have temperature control right then and there. I mean, that would keep the vehicle running, because I don't know how much this thing would pull out, but I never measured it. But yeah, it can run AC or DC. And let's see. I guess at the time I didn't have a transformer for this, so I was using DC the whole time for about 4 years. But the iron still works, so you would think that the iron would be the one that burned out. No, the iron's fine. And yeah, it's just the board. I know it, so it's shot. So I respin the board. I put a nice solder mask on it. It'll be fine. And yeah, it'll be fine. So yeah, you get to work out all the bugs and all, fine tune all the components and stuff. So there's that. Working on. All right. So thanks again for the letters. I appreciate it. The stickers, that's great. And I'm gonna be on top of that, guys, from now on. Anyway, but yeah. Hopefully this year will be a lot better. Hopefully. All right. So just a quick update. I don't know how long that took, but I don't know. Hopefully we'll see a lot more of some more fun and electronics, stuff like that. And I'll try to put some more effort and time into going over the process of how everything's going, and try to keep you guys a little more informed this year. All right, I'm gonna do better on that. So thanks a lot. I appreciate everybody out there, and good night, ladies and germs. Take care.